Hi, I'm Dan Abel, and in this video we're going to calculate the magnitude of the force acting on a current carrying wire in a magnetic field. In a previous lesson, you learned how to calculate the magnetic force on a charged particle moving in a magnetic field. Instead, if you have a wire, you can think of it as a series of charged particles moving down the conductor. That's why the equation F equals I LB sine theta, where I is the current in amps, L is the length of the wire in meters, B is the magnetic field strength in Teslas, and theta is the angle between the wire and the field, looks so similar to the equation for a single particle in a magnetic field. In fact, if you recall that current is charge per time, then F equals ILB sine theta becomes F equals Q over T LB sine theta. And then a length over a time is a distance per time, which is a velocity, and we're back to F equals QVB sine theta. So essentially, both this and the single particle equation are really expressing the same idea. Here's an example of how to apply this equation. Here you want to determine the magnetic force on a zero point 0.6 meter wire carrying a current of 2 amps placed in a magnetic field of 0.1 Tesla. Start with the equation for a current carrying wire in a magnetic field. Plug in your knowns, recognizing that the angle, according to the picture, is 90 degrees, and then solve to get a force of 0.12 newtons. In part B, you're asked to understand the relationship between magnetic field and force by figuring out how much the magnetic field would need to be increased in order to double the force. So we go back to the relationship between force and field and notice that this is a linear relationship. We know it's linear because we don't see any higher order powers like squared or cubed or square roots. Because it's a linear relationship, doubling the field will double the force, or tripling the field will triple the force, or cutting the field in half will cut the force in half. The big takeaway here is that whether you are looking at a charged particle in a magnetic field or a series of charged particles moving through a wire in a magnetic field, any charged particle in a magnetic field will experience a force.